Let's take a quick moment to work a binomial probability question. If the probability of winning a game of chance at a carnival is 18% and you decide to play the game, what is the probability that you win 5 out of 15 games played? This seems a little difficult to answer with just some of our regular probability rules and concepts. So we have to stop and consider, is this appropriate for a binomial? Well, the first thing you want to know is if we have a two-sided outcome. And the answer is yes. At the end of the game, you either win or lose. You also want to have a fixed number of trials when you use the binomial probabilities, and in this case we do. We're only playing the game 15 times. Another criteria for a binomial to be used is if each of the games or plays are independent, and in this case they are. The outcome of one game does not influence the outcome of the next. And finally, the probability of winning a game remains constant for each try. In this case it is. Consistently there's an 18% chance of you winning on any given play. So yes, this is a perfect situation for a binomial. The moment I think I'm going to use a binomial, I start to case out what is n, p, and x. In other words, identify the parameters of this problem. Well, in this problem, we have 15 tries, or 15 plays of the game, so that's n. The probability of a success, little p, is 0.18, and I guess it kind of goes without saying here that a success is winning the game. So that's why p is set at 0.18. Thus, the probability of losing the game is 0.82, or 82%. And it asked us to find the likelihood of winning 5 games. So these are our parameters. Now we have options in order to solve this. We could use the formula, or we could use StatCrunch. For me, in this illustration, I'm going to show you StatCrunch. Here we are in StatCrunch. There's only a few clicks or sequence of clicks you need to know in order to get a binomial probability out of StatCrunch. First, you want to make sure you're on a spreadsheet page of StatCrunch. This will allow us access to the buttons. We'll click Stat, Calculators, and then navigate down to Binomial. The pop-up box contains a small graph to reinforce our results, and it allows us to enter the parameters of our problem. In our problem we had 15 for n equals 15. Our probability of a success was 0.18, probability of winning. And we want to know exactly, so we'll switch this to equal, exactly 5 wins. Hit compute. You'll see that the probability that we have exactly 5 wins is equal to 0.0779, etc. Likewise, you can see that the red bar here is our solution. It's just the one value 5. This is our answer again. And what it tells us is that there is a 7.8% chance that you will win exactly 5 times when the game is played 15 times. If we wanted to change the question to another problem, let's say we wanted to know what's the probability of winning more than 5 times. Then we can simply change the drop-down box here to greater than 5, hit compute, and you can see that it has updated the answer. This answer is 0.0387. And as you can see here, the bars greater than 5, that is 6, 7, 8, 9, etc., are all red, showing us it is the combination of all of these solutions.